We are discussing the chapter number 2, electrostatic and capacitance. Today we will discuss about the topic dielectric. Okay, already we come to know that what conductor is and what is insulator. Okay, now what is dielectric? We have to see. Let us consider this is a dielectric. Okay, this is a dielectric material. Here we can say that these are the molecules. These are the molecules. In the dielectric, there are no free electron. That is, there is no current carrier. Clear? If we apply an external electric field, let us consider these are plus, these are minus. That is, in this direction, electric field is there. Okay? We place the dielectric inside a electric field having intensity E0. That is, E0 is applied electric field. When we apply this electric field, then what will happen? What will happen? These charges, we can say that this is the initial state. E0 is equal to 0. When E0 is equal to 0, that is, there is no electric field. Okay, these are the molecules of dielectric behave like this. Okay, it will reside inside the dielectric like this. Now we apply an external field. E0 is not equal to 0, that is, there is an external field. Let us consider this is what? Dielectric. Okay, we place this dielectric inside an electric field. Then what will happen? These molecules, when electric field is 0, are behave like this. This is plus, they will be the electron, the molecules positive charge will repel back. This positive charge repel back these positive charges. That is, an electron are repelled by these charges. Therefore, electron will go like through inside the molecule like this and this. This is also minus plus. Okay, minus plus, minus plus, minus plus, minus plus, minus plus, minus plus. Clear? So there will be a negative sign here. That is, there will be negative and this will be positive. Because what? These positive and these negative only behave as positive or negative charges, because these positive and negative cancel each other, these will cancel each other, these will cancel each other. Okay, all are cancelled by each other. Only the ends positive and negative charges will be there. Clear? Okay, therefore there will be another electric field from positive to negative. This is called induced electric field. Induced electric field. Okay, this is what? Induced electric field, from plus to minus. Okay, that is what we know that in the conductor, the free electrons will move from one side to other, but and in the in the insulator there will be no such carrier, and the molecules of insulator will not experience any electric field. But in dielectric there will be no free electron. Therefore, current cannot pass through the dielectric. But the molecules inside the dielectric can experience electric field, that is external electric field, and they can polarize. They can change its polarity. That is what? This was the plus and minus coincide in the molecule, and after application of external electric field, they what? Polarize itself, and minus goes to the positive charge and plus to the negative charge. Therefore, they will produce an external induced electric field. Okay, which is E induced. Clear? Now, what will be the total electric field in the dielectric? So therefore, the total electric field E in the dielectric is equal to applied electric field, which is in the direction from this to this side, plus E induced electric field. Clear? But the induced electric field is opposite to the applied electric field. You can see this is the direction of applied electric field and this is the direction of induced electric field. Therefore, we have to change its sign. Okay, so what is total electric field? Total electric field is E naught minus E induced. Clear? Okay, these are the surges. If sigma p are the surge is the surge density of the dielectric. That is what here. This is sigma p. This is also same. So let us consider sigma p is the surge density of the dielectric. Clear? Then we can also write E induced as E polarization. Why? Why E induced is created? Because of polarization. Therefore, we can also say E induced is same as E polarization. Clear? So we can write E naught minus E polarization. So is equal to how much? E naught minus E. Now, E polarization is dependent on what? How much polarization will occur is dependent on the material, that is the permission given by this material. What permission? Electric permission. Therefore, E is there. E is the epsilon is the electrical permittivity of this dielectric, and what is how much polarization is occur. Okay, we can write EP is equal to sigma by okay, polarization means we can say that's how much charges occur. We can replace it by sigma p. Okay, how much polarization density increases and what is the permission given by the dielectric is what? E, polarization electric field. Therefore, we can write E is equal to this equation. 1 implies E is equal to E naught minus sigma p by epsilon. Okay, write down dielectric constant. We have already come to know what dielectric constant in chapter 1. Okay, also here we can write dielectric constant is the ratio of electric field. Oh no, that is the ratio of applied electric field to the ratio of applied electric field to the total electric field. Okay, that is what we can write. What? Dielectric constant K. We can denote dielectric constant as K or epsilon R. We know that, which is equal to how much we say dielectric constant is the ratio of the applied electric field to the applied electric field is E naught here, and what is the total electric field? E naught by EP. E naught minus EP. Okay, this is what. Now we can continue here from here. Okay, K or K is equal to what? You know this what? Sigma by epsilon naught. What is sigma? This is sigma, charge density. Okay, sigma by epsilon naught, and this is also sigma by epsilon naught. And what is EP? EP is what? Sigma P by epsilon. So sigma P by epsilon. So if this is epsilon naught, then this will be sigma by sigma minus sigma P. This is what? The case of air. Okay, epsilon naught, air or vacuum. Okay, we can consider as other medium as sigma m or sigma. Sorry, not sigma, epsilon. Sorry, epsilon naught for in case of what? Air. Okay, for other case we can consider as only epsilon or epsilon m. Clear? So this is what? Dielectric constant. Okay, next, what is polar and non-polar molecule? Okay, now we will discuss about polar and non-polar molecule. Okay, now first, non-polar molecule. Okay, if the total positive and negative charges are coincide, then if the total positive and negative charges are coincide, then the molecule is called non-polar molecule. Okay, if the total positive and negative charges are coincide, then the molecule is called what? Non-polar molecule. For example, hydrogen, oxygen, carbon dioxide, etc. Okay, let us consider carbon dioxide. Carbon, oxygen, right? 2 electrons are shared. Here are 2 electrons are shared. Total electron is how much? 4 electrons in carbon, and there are 6 electrons. Okay. 6 electrons are there in oxygen. Outermost cells are considered. So this is what? This is the carbon. So total charge of the oxygen and oxygen is here. So these charges are balanced. Okay, so the charges of positive of all the carbon, this is carbon. Okay, there are also its positive charges in the nucleus. So this is balanced. That is, inside the carbon, all the positive charges will be coincide with the negative charges. Therefore, these are called what? Polar, non-polar molecules. Okay. For example, what? Hydrogen, oxygen, carbon dioxide, etc. are non-polar molecules. The total positive charges coincide with the total negative charges. Okay, the coincide in the carbon. So it is called non-polar molecules. Actually, it is dependent on the symmetry of the molecule. Clear? Next is polar molecule. Okay, what is polar molecule? If the total positive and negative charges are not coincide, okay, that is what? Not coincide. You just write the same line, not coincide. coincide. If they are not coincide, then the molecule is called what? Polar molecule. Okay. For example, HCl. HCl. Okay. How many electrons in the outermost shell in the chlorine? There are how much? 7. 2, 8. 7 is its electronic configuration. Okay. Here hydrogen have only one electron. Okay. Therefore, its total charge will reside in the chlorine. Therefore, the positive and negative charges will not coincide in this case. Therefore, HCl is a polar molecule. Like that, NH3, not NH3. Let us consider H2. H2 is what? Non-polar, sorry, polar molecule. Clear? Okay. These are the polar and non-polar molecule. Next, polarization of dielectric placed in an external field. Yeah, electric. Placed in an external electric field. Okay, external electric field. Polarization of dielectric. Okay, we will consider first polar dielectric and non-polar dielectric. Non-polar dielectric in case of non-polar dielectric. Okay. First, we will consider what? Non-polar dielectric. Okay. Let us consider this is a dielectric. Non-polar means what? Positive charges and negative charges coincide. That is what? There is no distance between the charges. Let us consider this is positive and negative charges. This is what? Positive and negative charges. Is only these 6 molecules are there in the dielectric? No, there are crore molecules are there. For assumption, we consider only 6 here. Okay. Now, these are the initial state. They are coincide with each other. That is what? E naught, external electric field is 0 here. Okay. Now, we will apply what? We have already discussed it in the earlier class. In the earlier topic. When E naught is not equal to 0. Okay. That is what? That is okay. These are the plus. These are the minus. Therefore, this is the direction of applied electric field. Now, what will happen? When the applied electric field experience this dielectric, then it will behave like what? This will minus, this plus, minus, plus, minus, plus. This is what? Minus, plus. They will what? Minus, plus, minus. What will happen? The polarization occur. What? This where the plus is there, so plus is repelled by this electric field. Therefore, and attracted by minus charges. Therefore, it will polarize. Okay, all molecules are polarized. Clear? Therefore, the effect of these are cancel out, and only negative charges are there and positive charges are there. Okay, therefore, plus to minus a total dipole moment created. Okay, that is what here dipole moment P is what? 0. In every case there is no distance. Total is how much? 0 for every molecule. But when we apply an external field, then there is a total electric field, total dipole moment created. What is its distance? This is the distance. Clear? Okay. This is the polarization of dielectric placed in a external field in case of nonpolar dielectric. Or what? Nonpolar dielectric. Okay. Here electric field is produced, E polarization. Okay. Fine. Next is polar molecule, polar dielectric, nonpolar dielectric. So polar dielectric. The molecules are polar. So let us consider this is a dielectric. We are considering polar, that is there is plus and minus is there, and there is some distance. Some distance are there. Like all the molecules. What? Okay, this is minus plus. This is plus minus, minus plus, plus minus, minus plus, minus plus. These are the polar molecules, minus to plus, negative to positive. Sorry, the direction of, I forgot this, polar dipole moment is from negative to positive. Clear? So direction of dipole moment is same as the external field here. In this case of what? Nonpolar dielectric. In the polar dielectric, now we are applying external electric field to the dielectric. That is there plus and minus are there. So E naught is not equal to 0. In this case, what will happen? When the applied electric field is there, then this plus is repelled by the electric field and negative sign is attracted. Therefore, there will be what? Minus plus, minus plus, minus plus, minus plus, minus plus, and minus plus. Okay, minus plus are there. That is what? Negative charges are attracted by this. Therefore, this is what? Plus to minus, plus to minus, plus to minus, plus to minus, plus to minus. Okay, clear? So the effect will be decreased and there is only positive charges are in this direction and positive and positive. Therefore, positive to negative, there is an electric field called E induced electric field, and there will be a dipole moment from negative to positive. Total dipole moment is from negative to positive. Okay, these are the polar and non-polar dielectric in external electric field. What is happening? So when external field is 0, there are dipole moments in each molecule, and the total dipole moment in absence of the external electric field is 0 because these directions are random. Okay, therefore total dipole moment is 0 in absence of external electric field. Now when we apply the external electric field, then there is a total dipole moment from minus to plus. Clear? Because they are aligned due to the external electric field. The next point is dielectric breakdown. Dielectric breakdown. Dielectric breakdown. What is dielectric breakdown? Okay, here you can see when external field is there is a dipole moment from negative to positive. Now if we increase the external electric field, increasing to a very high value of electric field, then the dielectric will break. This dipole moment will break, and these charges can move from one side to other side. Then this dielectric converted to what? Dielectric is converted to what? Conductor. Next point is what? Electric susceptibility. Electric susceptibility. Electric susceptibility. Okay, what electric susceptibility? We know that polarization is directly proportional to total electric field. Okay, that is polarization P is proportional to applied electric field E. So we can write P is equal to chi, so it is called chi E. To make this chi dimensionless, we use epsilon here. Okay, this is what? Polarization. Chi is called electric susceptibility. Okay. Now we can write chi is equal to what? Polarization by epsilon E. That is what? Chi is the ratio of polarization by total electric field. Okay. What is electric susceptibility? Electric susceptibility is the ratio of polarization to the applied and total electric field. Okay, susceptibility is the ratio of polarization to the total electric field. Okay, now we can find a relationship between electric susceptibility and dielectric constant. Relation between electric susceptibility and dielectric constant. Okay, now we can find the relation. Clear? Okay. We know that total electric field E is equal to E naught minus E. Okay, so E is equal to E naught minus, what is EP? EP is the polarization, okay, divided by epsilon. Clear? Now what is polarization? Already we know that, come to know that what? Polarization is epsilon, chi and E divided by epsilon. Therefore E naught minus what? chi E. So this is what E. So E naught is equal to E plus chi E. Okay, so we can common out 1 plus is equal to what? E naught. Write down. Now E naught by E is equal to 1 pi chi. What is E naught by E? What is E actually? E is equal to what? 1 by 4 pi epsilon naught Q by what? R square. Okay, E naught. And what is E? 1 by 4 pi epsilon M, that is epsilon, divided by Q by R square. So E naught by E is what? E naught by E is what? E naught by E is 4 pi, so 4 pi cancel. So no, we cannot cancel it out. 4 pi cancel out. These are cancel out. So E naught by E is what? Epsilon by epsilon naught. No, no. Okay, epsilon naught is done. It will come. Okay, epsilon by epsilon. This is called what? Epsilon R or K. Okay, that is what. So E by is what? T is equal to 1 plus chi. This is the relationship between what? Electric susceptibility chi and dielectric constant K or epsilon R. Okay, thank you.